Okay, now we're going to be looking at exponential functions. So new unit, new concepts, and so it's sort of going back to some stuff that you may not have looked at since grade 9. So first of all, what I want to do is I want to remind you a little bit of powers and exponents, and we're going to learn what's called some exponent laws today. So the reason we use exponents is because that large numbers can be really awkward to write. Sometimes it's easier to work with them when they're written in exponential form. So you can see we've got all the parts right here for what's called a power. So 2 to the 3 is called a power. So those two parts taken together make up a power. The exponent is actually that little number at the top in green in our diagram. The base is the bigger number that it's on. So again, taken together, they're called a power. And what a power means, so 2 to the 3, means 2 times 2 times 2, which is not 6. Sometimes people confuse powers with multiplication. It's not 2 times 3, it's 2 times itself 3 times. 2 times 2 is 4, and then times 2 again is 8. So that's a pretty relatively small number, 8. But you can imagine how big the number would be if I had, say, 2 to the 100. Again, that wouldn't just be 2 times 100. It's not 200. It's 2 times 2 times 2 times 2, etc., 100 times, which would be a really big number to write out. And actually, it's a really big number when you multiply it out, too. So exponents are actually good things. Powers are good things. They let us write really really long things in a short form. So you know this. At least you've been taught this, and there's a reminder of it. But here are some things that you may not know. You may have been taught this and forgotten it, but I think you might not have seen this yet. So we're going to look at a few rules, a few laws. So the first one is if we're multiplying powers with the same base. So we're multiplying and they have the same base. The same base part is really important. They have to have the same base. So base, again, is that big number. It's in red in this thing. So this will only work if we have the same base. And we'll see why in a second. What happens if I multiply 5 to the 2 times 5 to the 4? Well, 5 to the 2 just means 5 times 5. And 5 to the 4 means 5 times itself 4 times. And we're multiplying these together, right? So when you multiply it, because it's the same base, the blue 5s are the same as the green 5s. I just did them in a different color so that you could see where they came from. But 5 is 5, no matter what color I write it in. And so it turns out that we've actually got 6 5s here. And then I could put that back together and say, well, if I've got 6 5s multiplied together, that's the same as 5 to the exponent 6. And so if I do the same thing for this one, 3 to the 5 just means 3 times itself 5 times, which is, even with that relatively small number, kind of a pain to write them all out. And then I got another couple of 3s multiplied together. All that matters is I've got 7 3s. And so that combines into 3 to the exponent 7, because we're multiplying 3 times itself 7 times. So rather than writing all this, well, actually, I take that back. I am going to write it out a couple more times. So negative 2 to the 3 means negative 2 times itself 3 times. Let's do different color again for the other one. We got a couple more negative 2's. Brackets, I don't have to write the multiply sign down. How many negative 2's do we have? Well, we've got 5 of them, so it becomes negative 2 to the 5. Notice how I've kept the brackets around it, because that's something about exponents which I should get out of the way right away. You're going to need to remember this. Exponents are on what they're immediately beside. So negative 2 to the 5 in brackets, that 5 is right beside the whole bracket. Let's take a smaller number so I don't have to write as many out, but let's compare a couple things. Negative 2 to the 3 is a pretty small one. That means negative 2 times negative 2 times negative 2. Actually, I'm going to do it to an even exponent. Let me just change this up. Let's do it to the exponent 2. That's about as small as I can get. So negative 2 to the, in brackets, to the 2 means negative 2 times negative 2. We know that when we multiply a negative times a negative, we get a positive, and that equals 4. Let's drop the brackets. Let's do the same thing without brackets. Let's just do negative 2 to the 2 without brackets. Remember, the exponent's only on what it's beside. So this 2 exponent is actually only on the 2 base. It's not technically touching that negative sign. Up here, the 2 is touching the negative sign only because everything's inside the brackets. The 2 is actually on the brackets. So that changes our answer. That means I've still got the minus sign out front, but really I'm just doing 2 times 2. So now I've got a negative times a positive, and so the difference between these two answers is one's positive, one's negative, and that's all just because of the negative, or because of the brackets. So you really do have to pay attention to the brackets for exponents. It matters. The short form, just to sum up this, or the short rule of thumb to sum this up, is anytime there is an even exponent, like 2 or 4 or 6 or 8 or 10, we're going to get an even number of negative signs multiplied together, and it'll come out positive in the end. Anytime there's an odd number, and this is going back to things that are in brackets, strictly things that are in brackets, then what we're going to get is an odd number of negative signs when we multiply things together, and so this will end up being, this one would end up being negative 8, because I've got 3 negative signs, and then 2 times 2 times 2 is 8. So odd versus even exponents will give me different plus or minus answers as far as those go. And then just if there's no brackets on a negative 1, it'll always be negative. All right, back to this one. Doesn't matter if the fraction is, or the base is a fraction. I can do a half times a half times a half. That's what the first one means. I'm going to multiply that times one more, 1/2. Made a bit of a mess of that bracket. Let's fix that. How many 1/2s do I have? I have 4 of them. So then I have 1/2 to the exponent 4. Again, I need the brackets. If I don't have the brackets there, it means something different. Let's take a look at it once more. 1/2 to the exponent 2, like this, means 1/2 times 1/2. And if we multiply fractions together, remember it's top times top. So 1 times 1 is 1, and bottom times bottom. 2 times 2 is 4. Okay? If I go like this, 1/2 to the 2 like this, again, what do we assume that the exponent is on? Well, it appears to be beside the 1. Exponents are immediately what they're beside. They're on immediately what they're beside. So this would just be 1 times 1. 1 squared for the top would still just equal 1/2. Whereas in this case, this exponent is on the bracket and everything that's in it. So we get different answers again. Brackets matter. All right? So that was an aside. Let's get back to what we were originally supposed to learn from this example. What you may hopefully notice is that when we multiply powers, right, we're multiplying in each case. Let's highlight. Multiply, 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 multiply. We're multiplying powers. What happens is if we add 2 and 4, we end up with 6. If we add 5 and 2, we end up with 7. The base doesn't change. So in every case, if we add the exponents together, then we'll get the new exponent with the same base. Well, what's the exponent that's assumed to be on this last one? If there's no exponent written here, we assume that's a 1. So that's why we do 3 plus 1, and we end up with a 4 over here. So the answer is, or the rule is, if we have 2 powers, and we multiply it, and they have the same base, and we add them together, right, This is a power here, just any old power, a base and exponent together. Here's another power with a base and an exponent together, and they have the same base, which I'll highlight by highlighting in yellow. They both have base A. As long as it's the same, it can be A or B or 3 or 10 or -5. As long as the bases are the same, then we can add the exponents together, and the rule becomes same base, added exponents. So this is a rule you need to be familiar with. When we're dividing powers, moving on to the next part, so the first one we did was multiplying. Now we're dividing. Let's take a look at one example, see what happens. 5 to the 6 means 5 6 times. Already, again, not fun to write all those 5s out. 5 to the 2, I'll do that one in green. So I got a couple of 5s here, but that's it. When we've got things that are just multiplying and dividing like this, remember we can cancel out things that are the same that are on the top and bottom. So I can cancel one 5 on the top with one of the 5s on the bottom, and then another 5 with another 5 on the bottom. What we're left with is 4 5s. So we will end up with 5 to the 4. Okay, for the next one, I've got 5 3s. And on the bottom, I've got 3 3s. I'm going to cancel out the ones that I can, so this will cancel, cancel, cancel. I'm left with 2. That's the same as 3 to the 2. So we can probably already imagine what's going to happen here if we have division. All these are about division, and I've got a 6 on the top and a 2 on the bottom. That ends up being a 4 because I've subtracted. A 5 on the top, take away 3 of the 3s from the bottom, and I'm left with 2. We can imagine what's going to happen for the next one if we understand that. We're left with 1. Did you predict that? Because you should have. We have the base the same, -7. Pen stopped writing properly all of a sudden. Wonder. Let me just check how charged up my pen is. It's still good. Okay, it's just a glitch. All right. So -7 to the 1, because we do 3 minus 2 equals 1. And this last one's just written a different way. If we divide, we could write divide the same as this. We could have 4 7s, sorry, 7 4s. We could have 4 4s on the bottom, or divide by 4 4s. Means the same thing to write it like this. We'll cancel, and we're left with 3. So our rule, when we're dividing, is that we are going to subtract the exponents. The base remains the exact same. So whether it's a or 4 or -7 or 3 or 5, like in the examples, as long as the two bases are the exact same, they're both a, then I don't write I don't repeat it, but I just write it one time, and then I'm going to subtract the exponents. So these two rules are just opposites of each other in a way. If I multiply, I add. If I divide, I subtract the exponents. So it's a really nice shortcut. The last one is a power within a power. And so let's take a look at what this last rule is going to tell us to do. So we know that that powers or exponents are on what they're immediately beside. So let's take a look at this here. We've got a 2, and that's actually on the bracket that's beside it. We've talked about brackets already. It's on this whole thing here. So in other words, I'm doing 5 to the 3 times itself twice. So literally it means 5 to the 3 times 5 to the 3, right? I just have the base times itself. So make sure you're clear on that first step there. Because from there, then it's an easy enough step to understand that this 5 to the 3 then becomes, well, actually, I don't even need to write it out. I'm not going to write it out. You know what? I'm just going to go back to my exponent laws. If I understand what this means, then I know that I can add this 3 and this 3 together, and so it works out to be 6. Maybe I do need to show it. I know I'm changing my mind as I go along, but for the first one I'll show it. I just want to be really clear. So this first one, we've got 3 5s. From the second one, we've got another 3 5s. Really, we're just going back to the multiplication law, right? But we had a step before we got to the multiplication part, and that step was to realize that we can multiply powers times themselves as well. So we got 6 factors. It combines to a single power of 5, the base was 5, to the 6. Okay, so for this next one, that means we got 3 squared times itself 4 times. I don't have room to write them all out, but if I did write them all out, how many 3's would I have? Well, I'd have 2 plus 2 plus 2 plus 2. I'd end up with 8 3's, wouldn't I, if I wrote them all out? That could be rewritten then as 3 to the 8. In this last one, I have 4 to the 3 times itself 3 times, which again, if I had room to write it all out, I'd have 3 4's and another 3 4's and another 3 4's. I'd have 9 4's, which means that I could write this as 4 to the 9. Do we have a shortcut that we can see to jump from the first column to the last column? Well, I've got a 3 and a 2, and I end up with a 6. Well, 3 times 2 equals 6. Let's see if that works. I've got a 2 and a 4. 2 times 4 equals 8. I've got a 3 and a 3. 3 times 3 equals 9. So if I've got a power of a power, now I'm going to multiply the exponents together. So the base is still a, but the exponent becomes p times q. And so, again, really easy, but you just have to be clear on how you're looking at it. You have to know what's going on. Because, to summarize, when we're multiplying powers with the same base, we add. Multiplying means add exponents. If we're dividing powers with the same base, we subtract. Divide means subtract. And if we're raising a power to another exponent, then we multiply the exponents together.